welcome to the stage Nikos Tsiligaridis, WeatherXM CTO, co-founder and principal embedded systems developer. Welcome.
Hello, Nico.
WeatherXM is the world's largest and fastest growing community-powered weather network. It provides accurate, hyper-local weather data and services to individuals and enterprises and enables new web3 services that were not feasible until now. Nikos will be talking about WeatherXM, the evolution of a web3 IoT startup.
Welcome, Nico.
Welcome.
Άμα έχεις clicker. Θα το δουλέψει ή θέλει πάλι το kernel. Τέλεια. Καλησπέρα. I want to show you a map. So each of these dots you see is a Web3 enabled weather station. Each of these stations contributes data with cryptographic proof to a Web3 infrastructure. This is the fastest growing network of weather stations in the world. And the owners of these weather stations are rewarded with our native WXM tokens for making sure that these weather stations keep running and for maintaining them. So utility companies, farmers, or people just like you and me, they can purchase these tokens and use them to exchange them for weather services or weather data in a decentralized marketplace. Or how about some fancier stuff? For example, on-chain decentralized parametric weather insurance. Sounds like a plan. I am Nikos, CTO and co-founder of WeatherXM, and I will take you through a short journey on how a small IoT company scaled to become the fastest growing Web3 decentralized community-built weather station network. But first, let's go back to Web3. So we started as a small company of 5 engineers about 7 years ago. We started building IoT solutions in an effort to solve challenging enterprise problems. And it didn't take long before we were approached by various companies from the industry. And such companies include, for example, airports or motorways, energy utilities, and others. So since most of our solutions revolve around environmental data, and especially weather data, it didn't take long for us to realize that there's just not enough of it. So most of the planet lacks weather data. And where there is weather data, it's usually concentrated around cities, around city centers. And the result of this is that we have inaccurate weather services. And let's see an example. This is a forecast for Athens for yesterday's forecast from 4 different services. The blue line is one of our own weather stations that shows what actually happened. So essentially, this is what was forecasted versus what happened in the end. And you can clearly see the discrepancy between the services and the actual data. So we thought, how could we tackle this? What if we could build a low-maintenance, low-cost, completely autonomous weather station and flood the world with it, essentially creating a dense network that could effectively solve the data scarcity problem? So we dreamed about it, discussed it again and again, and meanwhile we had to pay the bill somehow, so this dream had to stay on hold for a while. So to realize our IoT solutions, we tended to improvise with off-the-shelf hardware, custom firmware, and maybe expensive industrial weather stations or other expensive sensors. But we were never really fond of this because off-the-shelf usually means Arduino. And to me, as a hardware engineer, Arduino is almost always bad news because it usually means bad quality hardware, bad libraries, and the spaghetti ecosystem. So it's a disaster for a recipe for disaster. But the risk for a small company like ours to build our own custom hardware is pretty high. And because the time to market is of the essence, we kept doing what we could with readily available hardware. So let's see a few examples. One of our earliest IoT projects was a noise monitoring system for airports. So an airport approached us with a problem. How could they correlate airplane noise pollution with aircraft type or maybe takeoff style or landing style of the aircraft, along with weather conditions. So the goal was to set up guidelines for the future in hope to reduce pollution. So we came up with a complex solution. We took public flight data and along with noise data that came from sensors that we placed along the runway. These sensors would record airplanes landing and taking off, and all this data would end up on our IoT platform. This data would be fed to a machine learning algorithm, which then would output statistical and visual data describing the patterns that were calculated from the noise profiles of the airplanes. So we tried to approach this with readily available sensors as usual, and not so reliable SDKs, of course. And we hit many, many roadblocks. So what was the result? The result was a system that actually delivered what it was promised to deliver, but at what cost? So the system proved to be high maintenance, and autonomous actually meant manually operated. And this resulted in many, many field trips, happy field trips to the airport, where we stayed all day fixing problems, as you can see in the pictures. So there are small lessons in this. What we learned is that the iceberg principle that we all know is especially true for hardware. So there's much more than meets the eye. And usually the fastest and readily available solutions usually end up wasting more time when time comes to fix the problems that they caused. So we learned a lot from our mistakes, so let's do some more and learn some more. Having learned from these past mistakes of plug and not play hardware, we decided to build our own modular system. So essentially, we would choose our own low-level components and in a way choose our poison, so to speak, because we would not lock ourselves to a certain ecosystem. So we handpicked a few modules, threw them on a custom carrier board, designed a 3D printed enclosure, wrote new firmware, and the result is this. It's a fully energy and completely communication autonomous sensor node that supports a range of sensors. It's built for low maintenance, remote deployments, and harsh weather environments. With the help of the Hellenic Marine Research Center, this product quickly became one of our most deployed hardware to that date. It is used, among others, to build Greece's largest network of sensor nodes that monitor surface water parameters, such as water level or water quality and others. And it is deployed in at least 50 locations around Greece. So this hardware worked well, but we still weren't quite happy with it. The solution still was not scalable, at least not easily scalable, and came with a few drawbacks of the ecosystem. So fast forward a few years to 2018, having been tired of limitations of off-the-shelf, readily available hardware, we decided, why not build our own hardware? Why keep fixing other people's problems and bugs when we can build our own and then spend this time fixing our own problems? Sounds good. So it was time to finally build our own hardware. So we joined HAX. HAX is the world's largest accelerator for hardware startups. It's located in Shenzhen, China. And this is where we traveled. So we traveled to China, stayed there for a few months, and threw ourselves into finally building our weather stations with all the goodies and everything we ever wanted, all the freedom we wanted. So a few months later, we have it. We have our precious weather station in our hands, nice and shiny and beautiful. Looks like we built the world's first fully featured, connected weather sensors with quite a few innovations in weather sensing. It could do everything you can imagine. So now we're back in Athens. But who's going to buy it? So there's a small lesson there. Be certain of the product market fit, especially before you go and start building hardware. But the most important lesson is this. Hardware is hard to make, sell, and scale. So you need to sell a service along with it, hard enough, with enough force that it drags the hardware with it. And this is where Web3 comes into play. So we have been watching the Web3 space for a while now for interesting projects, but we had to see up close what the hype was all about. So we did what all the engineers do. We built a quick and dirty system to see the inner workings. So we built a proof of concept based on Ethereum and Chainlink using a special version of our hardware that sent the data directly to decentralized storage, that is IPFS. And we published it. Soon after, Protocol Labs and Consensus found out and reached us, and got in touch with us, offering help in form of capital and advisory support to help and move this forward. So we joined their accelerator, the Tachyon. The idea was simple. Users buy our weather stations. Each comes with a special crypto chip. This crypto chip serves as proof that the data that came from this weather station is actually from that weather station, and also proof of ownership of the weather stations. The owners of the weather stations, are rewarded automatically by our smart contracts. For every day, they send proper data to the network, so the network rewards them. And this works like as an incentive to force them in a way to maintain the weather stations and make sure they're working. They're up and working. So data customers can buy these tokens and exchange them for weather data or services built on them. And the result is a weather data-driven economy, so where value is exchanged between weather data producers or weather data consumers. And things took off from there. A few months later, to test the waters, we put one of our weather stations, just for fun, just to see what happens, on our eShop. Things were silent until someone discovered it somehow, I don't know, and posted it on Reddit. And this is where all hell broke loose. So we had a stock of 300 pieces, pretty much a random number we input. And it was obliterated literally in a few hours. A few thousand users appeared in our Discord, suddenly out of nowhere. So to handle this demand, we immediately partnered with Chinese manufacturers. So 2 months later, we were ready to ship 1,000 more units. But in the meantime, we had 17,000 users line up in our waiting list, waiting to order. So when we opened sales, when we opened finally the sales 2 months later, from our side, it looked exactly like a DDoS attack. So everything crashed. And we have a small lesson that we learned from this, is that when you finally manage to find the product market fit, do not underestimate the demand that might come with it. And that was almost 1 year ago. And now we're in the present day. So we have 3 weather station models for sale, and more are under development. We have sold 5,000 weather stations, and a total of 11,000 will be manufactured by the end of the year. So we're the fastest growing network in the world. For example, the Greek Observatory operates about 500 weather stations, or NOAA, which is the US equivalent, operates 14,000 weather stations. And we're getting there. We'll be there soon. We have more than 9,000 members on Discord. A few months ago, we had a successful round, seed funding round, so it was a 5 million round coming from top VCs. We raised 5 million from top VCs of the Web3 ecosystem. Such VCs are Protocol Labs, Consensus, D-Lab, Placeholder. And we had 2.5 million revenue in station sales. And finally, what once was a 5-people company is now a 27-people company and still growing. As we're growing, we're looking for developers, tinkerers, enthusiasts to join us. So together we can make When Moon come true. Come talk to us at our booth if you're interested to join or just for a chat. Oh, by the way, we also have a lottery draw. I forgot about that. We have a lottery draw at our booth, so definitely do come. Thank you.
Thank you very much, Nico. I'll come to know the weather for tomorrow. You can leave it there.
And we would like also to thank WeatherXM for being a silver sponsor in our conference.